All. My name is Stelios-ARMS-CC. I'm coming from the Technical University of Crete in Greece, and today I will present you the work with the title An Intercloud Architecture for Future Internet Infrastructures. I have here my email, so if you have any questions, please feel free to contact me after the end of this presentation. Right, here we have the agenda. I will speak about cloud computing, the need for something extra, what are the requirements of the intercloud, and I will also present the intercloud model along with the specific experimental analysis. I have produced 4 different kinds of experiments there to demonstrate how we can achieve an intercloud service that acts as an intermediate in the communication between the clouds. These clouds actually are composed from different kinds of environments, like an OpenStack environment, and also we have the data center resource management system of the Fireware project, and finally we have an Amazon Web Service cloud, and we use these APIs. Of course, at the end of the discussion, I will present a few ideas about the future steps of our research. Right, so what is cloud computing? My perspective about cloud computing is that we have different kinds of processes, different kinds of systems that have dependencies, that have relationships, and these are all installed in our local data centers and local computers. So we move all these kind of processes to the cloud. We don't care about how this works, but someone else does the monitoring, the operations, and so on. So move processes to the cloud, to a remote data center, and we don't care about management. So in a cloud computing infrastructure is an infrastructure for delivering bespoke and on-demand services using the public internet. The high availability and service elasticity characteristic is a key requirement for clouds. There are different kinds of models, like the software as a service, platform as a service, infrastructure as a service, that are related with the kind of, let's say, process that we deliver to the users. Of course, there are here hybrid models. There are different kinds of systems. So today, there are different kinds of vendors that deliver services using the cloud computing paradigm. The characteristics here is a system like that is fast, offers faster provisioning of applications. It is really easy to integrate. Usually there are kind of open source cloud systems. It offers a cost over consumption service, so the users pay for what they use. And of course, the flexibility by the use of virtualization is a key characteristics. Finally, the mobility access allows users to access their services from everywhere in the world. Doesn't need to be near to the data center. Right, so today there are different kinds, as I said, different kinds of cloud services, cloud vendors that develop their services. Yet, customers somehow need to transfer service between clouds because they have decided to move from a cloud system to another one that offers better characteristics, better pricing models, and so on. But this is a problem that cloud computing has today. There is no support for a common, let's say, coordinated system where users could be able to access access the resources and the services that belong to different clouds. A good example is Amazon, for example. Amazon has different data centers that are spread in different geographical locations in the United States, okay? But there is no common coordination of these clouds. For example, for outsourcing requests from one data center to another. And of course, when you create a new system there, you need to somehow select your preferred location. Okay, so the quality of service depends on the user decisions. Other solutions are like HP, Intel, and Yahoo. They try to create interoperable clouds, but these are vendor-oriented, and usually researchers don't have full access to these kinds of test beds to try to implement their services. So intercloud, the way that we envision intercloud is how we can expand cloud data center capabilities by providing a flexible initiative for certain resources. We have different kinds of services here from different cloud providers that will be geographically distributed. So we have a distributed computing system. This is dynamically scaled. This means that we can actually increase or decrease the request for a service based on the actually resource capacity. So an intercloud is a dynamically distributed system with topology. And the viewpoint here is that the intercloud environment is composed of different cloud infrastructures, and we have different kinds of users that develop their services, develop their applications using this kind of services that are offered from different kinds of virtual infrastructure providers, different cloud providers. So here I have an example, just try to demonstrate how the cloud and the intercloud architecture exists. We have a user submits a request for a cloud, and usually there is a broker kind of input point, okay, and this broker is the, let's say, the management point, has access to the data center. I'm here. The data center is composed from different kinds of hosts. Then we generate their virtual machines and we put their services. When we create a new application, we're supposed to use different kinds of services that are offered as virtual machines. On the second hand, we have the cloud, the two cloud communication here, and then the cloud that acts as a glue. In this point, we have to put a coordinator on the top of the data center, or even better, it could be deployed in a virtual machine that will be able to make this communication between the clouds. Right, so we try to create a solution here based on open standards, and we try to create it based on OpenStack. OpenStack is a cloud software solution that offers a massive scalable cloud operating system. It is a very large global collaboration of developers. There are cloud computing technologies there that are trying to create open source cloud computing platforms. And the good thing is that it is founded by Rackspace, it is hosted by NASA, and there are at the moment many efforts in improving OpenStack and developing new solutions with this. I have here a diagram, not a diagram, just a figure to show the OpenStack community. There are companies like IBM, HP, Ubuntu, others like Cisco, Intel, okay? Usually all these vendors try to create solutions based on OpenStack. Right, so let's see the intercloud model that we have developed. It is based on OpenStack. It is designed to be flexible, and it's actually a service that is deployed. It's deployed in a cloud environment, and it is easily configurable. You can go there and configure the tenants that you have in an OpenStack cloud, and then you could be able to automatically connect to all these clouds and do specific issues, specific stuff at the moment. Also, it offers endpoints, solutions for Amazon Web Services, OpenNebula, and the VMware vCloud API interfaces. I have here an example, a simple figure. An OpenStack environment is composed of different kinds of services, the same of the AWS, the Amazon Web Services, and we have the intercloud service that acts as an intermediate between those two. The idea is that there are requests made using the RESTful interface for OpenStack and AWS, and we usually create this kind of service to interact with these environments in order to make requests to get values for both clouds. The intercloud model that is based on the OpenStack solution. We have a kind of intercloud registry. We go there and we create the tenants. We register the tenants. We register also information about the cloud, about the IP addresses, the ports of the endpoints, and then when you run the intercloud service, it gets information from the intercloud registry and accesses the intercloud services of the specific cloud. We have almost access to all of the services that offered, like the identity service that is for authentication, the network service for the networks, the internal networks of the cloud, the image service shows the available images that will be instantiated to be instances at the later stage, the security service with regards to the security issues of the virtual machines, like the ports that will be open and so on. There are different kinds of solutions here. So at the moment, the first version of our service is based on the identity, on the image, and to the network service. In the future, we will implement this for all of these kind of services. Right now, we try to create an intercloud based on different clouds. So we use the OpenStack environment, we use the Amazon Web Services and the API that is offered from Amazon, and another solution that is called FileWare DCRM, the Data Center Resource Management. Actually, FileWare is a new project that emerged in Europe before 2 years. It is a kind of solution that offers modular software that is deployed in the cloud in order to build next generation future-ready applications. There are different kinds of European projects based on FileWare. One is the FileStar project that I will speak in a while, that I work also for FileStar, and we're trying to create their applications for the healthcare domain. Actually, we also try to explore how we can use this intercloud service in order to offer a common management point for clouds in the healthcare domain. So, as I said before, OpenStack, it is the base that we have as designers, and we use the API to access services like the identity service, the image service, the network, and the compute. Right, let me present you the intercloud as a service and the experimental system that we have created. You can see here it is the intercloud service. It is actually a service deployed in the cloud, in a virtual machine, and we can have access to an intercloud, to the Intel Cloud system, that is the cloud system of the Technical University of Crete, that has almost 120 cores. Access also to the FileLab. The FileLab is the FileWare cloud environment based on this FileWare DCRM-CC. This is the name of the solution. Also, we have tried to access a VMware, the vCloud, and used the specific API that it offers. And finally, we have access to the Amazon Web Services. We have created an account there. We try to access it using the API, and the Cloud Lab. The Cloud Lab is a cloud experimental infrastructure that we have here in the Technical University of Crete just to make experiments. The Cloud Lab offers actually an OpenStack environment and an OpenNebula. OpenNebula is an environment similar to the OpenStack. It is open source and offers a platform for virtualized services. Right, so in order to present our experimental study, we have created this kind of intercloud as a service, we call it that way, that exposes interfaces to internal procedures for further communication among clouds. We have three kinds of metrics. The first is the real metric, that is the wall clock, and as I said, here is the time needed from start to finish of the call. The call is actually a call that is made from the service to the cloud environment. We have the user, and is actually amount of CPU time spent in user mode. It is outside the kernel. And we have the sys, which is the amount of CPU time spent inside the kernel. So we say that we have two kinds of metrics for the amount of CPU outside and inside the kernel. And then finally we have the factor, which is the actual performance of the metric. And we decide the factor by making a division of the worst and the best value of a call. In order to demonstrate the experimental study, we have 4 kinds of experiments. The first experiment, we execute a call within a cloud to be used as a benchmark. Then we have a call outside the cloud using 2 clouds. Then we have 3 clouds and 4 clouds. Each time we try to change the cloud system. Okay, the first time we try with Cloud Lab, the second time we try with Cloud Lab and IntelliCloud, third time we tried with PhiLab, IntelliCloud, and Cloud Lab, and so on. So the first experiment, we have calls that made from the InterCloud as a service to the Cloud Lab system and PhiLab in order to collect these kinds of measures like the real user sees and to define the factor that will be used as a benchmark. We make calls from the Cloud Lab to the PhiLab, and based on this we have concluded to a factor that gives us a 54%. This means that the case that we have 2 cases here. The first case is the real-time response of a cloud for calls that made internally, and the real-time response of a cloud that calls made externally. In the case that we do external calls, we achieve 54% of the performance. This does not sound very high, but averagely we can see that we have a less than half second request call, time call, and this we feel that this is a realistic number for for an intercloud call. Okay, you don't have to wait higher. You don't have to wait more than 0.5 seconds. In the second external case, we demonstrate the intercloud service with calls that made from the service to Cloud Lab and to the PhiLab infrastructure. We started to compare here the responses for the case of PhiLab authentication in contradiction to the intercloud as a service. Now here the new factor is 42%, and in this case again we have realistic high levels of performance, because 9 out of the 10 calls have been completed less than 1 second, and again this is a realistic number. Of course, this is we need to consider here that we make calls from the Greek IntelliCloud infrastructure to the Spanish PhiLab infrastructure, so there is time in the real-time execution of the request based on the distance of the data centers. The third case, we present the intercloud mechanism to compare performance of the same calls between, firstly, Cloud and PhiLab, the Cloud Lab, in the PhiLab, and the Cloud Lab, the PhiLab, and the IntelliCloud. So we have 3 cloud requests. As we can see for this figure, the fluctuation of the intercloud as a service for 2 and 3 clouds is at a value of 0.225 seconds. So it's a really low number. Also the real time increases slightly over the 1.2 seconds. Again, this is a realistic number because the calls between 3 clouds increases the number of the bandwidth. Right, so we compared to the previous experiment. The factors in such cases are in very high levels, as it achieves 89% of the performance of experiment 2, so it is very near to the performance of the previous experiment. Now the final one is the external call to the Cloud Lab, PhiLab, IntelliCloud, and AWS to Amazon, that it is in the United States. So in actually we have data centers allocated in Greece, Spain, and the United States. The factors for comparison of the 4 clouds I will demonstrate in a moment. Alright, it's here. For real end user, I use also these performance metrics. 4 to 3 clouds we achieve 53% of performance. 4 to 2 clouds 47%, 4 to 1 cloud 20%. It is highly. You can see that in the case of the 4 clouds, with regard to the one that includes calls made internally, the performance is very low. But this is realistic due to the distance of the data centers in the case of the four clouds. One is in Greece, in Spain, and one in the United States. The same happens with the user. The CPU CPU clock performance is increased, and we can see here that from this diagram that the real time has been almost doubled. Actually, this remains slightly under the 2 seconds. So we have tried here to demonstrate that when we create an intercloud service that interacts with APIs based on the cloud providers, it is actually related with the distance of the cloud providers, because the actual service does not consume any specific time, and it behaves very good. In the case of the four clouds, we can see that it is almost near to 2 seconds. It's a realistic high number. It's a very good number for interacting with four clouds. This is also this demonstrates the authentication mechanism. I forgot to explain that the call that we made each time is an action from the intercloud service in order to perform authentication with the interacting services. I will try here to conclude and present you my future work. So this work presents an intercloud as a service that is easily deployable, and you can actually interact with an OpenStack environment, a firewall data center resource management GE, and an AWS API. Also have extended for VMware vCloud. The current version is a draft and supports basic functionalities, but we are currently working on this in order to integrate more things. A few things that I would work in the near future is how we can extend the RESTful APIs and schemes of the interactive clouds, along with the AMPQ models that has to do with the messaging that happens within the cloud. Also, we will try to expand intercloud services on the aforementioned clouds. I have to add here OpenNebula Cloud, and I would like also to mention that this work is part of the Future Internet Social Technological Alignment Research Project, which is a Future Internet Private-Public Partnership project called FIPPP, and we have worked on this in order to identify issues on intercloud collaboration between different kinds of clouds that are based on the firmware DCRMG, but we also extended for different clouds of cloud providers like the OpenStack. I will conclude here my presentation. I would like to thank you for attending this session. I have here my email, so please, if you have any questions, contact me, and also have here the URL of my website. You can contact me there and we can have a discussion on this. So thank you very much.